Greetings, learners. I am Mr. Matotie from the OR Tambo Inland District. I am going to be assisting you with geography. Today we are focusing particularly on the drainage patterns, but we are looking more at integrating the drainage patterns with map skills so that we are adept at both sides of the paper, particularly paper 1. Let us get going. Okay. First, we're going to drop a very common drawing that we know from our previous slides, and the patterns are well illustrated there. So we are not going to go deeper into the analysis of each, but you'll see that there we are looking at the dendritic pattern, which is defined as more like shaped, like branches of a tree, and then they are found over uniformly resistant rocks. The next one will be your trellis pattern. Your trellis pattern is found more in alternative hard and soft rocks, where you have got the hard parts being high-lying and your lower parts being the softer parts. And then this often gives you streams that run parallel to each other, but with very short tributaries dropping down from the ridge to the bottom, to the trough where you actually get the river itself. And then we take the radial pattern, as is usual in the English language, radiating from a central point and outwards. So this one is associated more with high-lying areas like your hills, your buttes, your craters. Just think about a high-lying area and then streams coming out from that area, radiating to lower-lying areas outwards. And then we look at the last one, the rectangular pattern. Here, the main stream and the tributaries meander at just about 90 degrees, almost at right angles. And the tributaries join the main stream at almost right angles. We're not particular at exactly right angles, almost. So you can say plus minus 90 degrees. They are found on jointed landscapes. Please, learners, don't say on landscapes with cracks, because we are more focusing on the joints. Or you can say where there are many faults, because the rivers tend to form along the fault lines. And then we will take what is generally accepted as the approach to mastering this section. You must know what the pattern looks like, or you must be able to draw it. Because either the examiner will give you the pattern and you identify it, or you will be asked to draw it. So you must be comfortable from both angles. Secondly, you must be able to describe how it looks like, and then also give the characteristics. Then after that, you must master the underlying structure, which is the geology that is determining the actual pattern. The focus of today will therefore be integrating these patterns with map skills, how you identify them on a map. I'm not going to be doing all these patterns because we have to manage time, but I'll be taking a few of them as we move along. Okay? Let's look at that one, the dendritic pattern. Looks like branches of a tree. Let me get my highlighter. I will use red here. Now let's look at the topo map. Okay? Look at that. The way the tributaries join the mainstream looks very much like there, where it is shaped like branches of a tree. So the confluence where the streams join, you'll find that it's got small angles. If you are going the mathematics way, it's got acute angles. Okay? And then we look at the next one, which is the rectangular pattern. Now, here we said the mainstream meanders at almost right angles. Okay? Let's see. There is the figure, And you can see those angles meandering at almost right angles. Let's see if you can see that on the topo map. Look at that. Okay? Now you can see the arrows are pointing at where the stream bends. And the bending, look at this area, is more at 90 degrees. So the bend is very, very sharp. And it speaks to the rectangular pattern of the stream. We'll take that bend as well. You can see clearly, very, very well illustrated there. Let's take that one as well. There's no way you can miss it if you understand that the characteristic means the mainstream bends or meanders at almost 90 degrees. Okay? Let's keep going. Now the radial pattern. Remember we said it radiates from a high point and outwards. So let's see. There is your topographic map, and let's see how it looks. Flows from a central point. So in this case, the central point will be there, and the radiation is outwards from the central point. Now let's look at the orthophoto map. There's Diabus, which is at a height of 1578 meters above sea level. Now, if you look at this contour line reading, 1420 meters, it is lower than 1578. So we are now coming down from the top of the hill to the sides. And look at the streams. There we go, radiating outwards. There we go, radiating outwards from a central point. Okay? Now, we are talking about a high point. You can give an example of a conical hill, of a butte, or of a crater. Any one will be clearly illustrated in the topo map. And the question from the examiner will be clearly pointed at what you need to identify. Learners, thank you very much. I wish you good luck for your exams, and may you do well. Remember, you have to study hard, you have to work hard, spend less hours sleeping, focus on your future. Again, let's keep it up. The warmer the blankets, the colder the future. Study hard and good luck. Thank you very much.